like to introduce myself to all of you. First of all, my name is Avneesh, and I'm one of the delivery managers in Caelius, and from past 4+ years, have been managing and delivering numerous MuleSoft projects. And along with me, Kajal Agrwal has been hosting the MuleSoft meetups from the Chandigarh group. She couldn't be here with us today, but she is an associate solution architect and has absolutely great coding skills. And she has also helped us to create this MuleSoft meetup and mentor it overall. So can we move on to the next slide? I would like to introduce you to the speakers today. I am very thankful to both Ishalveer and Beauty for volunteering to be at the speakers for this meetup. Ishalveer is a senior solution consultant in Caelius Consulting and have worked in cross-domain projects from past 2 to 4 years, and so does Beauty. She is also a solution consultant working in the MuleSoft space. We also have our friends from the Chandigarh MuleSoft community, and Himanshu Sethi is one of them who has also joined the meetup. We have all the RTF was actually a big topic to cover in one meetup. That's why we have extended it to the next episode, and all of us have together worked to create these 2 meetups. We will also have, along with Himanshu, we'll also have Dipankar in our viewers, in our attendees, and also Mehak Garg, who were the speakers in our last meetup. And they will also be helping us out in any questions that you people will be having during the course of this meetup, and all of them will be happy to help you. We also have Kajal here. So, hey Kajal, thanks for joining us. I know you've been running busy, but thanks for taking your time for being here with us today. All right, great. We can move on to the next slide. Let's talk a bit about prerequisites. The safe harbor statement, we are not promoting any organization in this, and whatever we are going to present are strictly for the learning purposes. This presentation is not for any promotional activities, and we don't hold any responsibility if the same use case or the solution for the use case is going to work for your business, strictly for the learning purposes. And now I would like to pass on to Beauty to take over, and without wasting any time, let's start with this event. Thanks a lot.
Yeah, thank you, Avneesh. So good evening, everyone. As Avneesh mentioned that we are building over the previous meetup, which we covered around on 7th April. And no worries if you people have missed out, we have the video on the Caelius Consulting YouTube channel, so you can go through that video. Talking about the previous topics which we covered in the last meetup regarding RTF, we have covered the topic of the architecture of Kubernetes cluster. Then we use the Azure Kubernetes service for Kubernetes cluster, and then we installed the RTF and we deployed an application, and then we tested that application using the command line utility and the Postman. Coming to the agenda of the day, these are the topics which we are going to cover, which is the self-healing mechanism in RTF. Then we have horizontal and vertical scaling. Then we'll be covering report generation and backing up the RTF, and then tokenization and detokenization, and then how we forward the logs in external sources in RTF, and then persistent gateway and TLS, and the last mile security. So let's make this an interactive session. If you people have any questions, you can drop your question in a chat window. Our team will try their best to answer them, and in the end we have very interesting trivia. So let's just sit tight and let's start with the meetup. Coming to the first topic of today's meetup, which is the self-healing mechanism. So many of you have used the different deployment model in MuleSoft. For example, we have the cloud up, on-prem, then one is this RTF. So one of them is the on-prem. Be familiar with the fact that if sometimes the servers goes down, and if you want that get back to your desirable state, you need to manually provision that. But that's not in the case of the RTFs. RTF has the self-healing property, which is that self-healing property in RTF means that it will ensure that the ability on the stability of your Mule application, which means that if any of your workers node goes down or if any of your container fails or become unhealthy, the RTF agent will try to create a replica inside a worker node to keep the number of replicas same as the number user provided during the deployment. And this is only possible because of the self-healing capability of the Kubernetes. So the idea behind this is that if any of the container gets failed, Kubernetes will automatically redeploy that container to its desired state. Then after that, the Kubernetes has two probe to gauge to this one. The one is the liveness probe and the second one is the readiness probe. So what this liveness probe does is that it will check the state running status of the container. So if any of the containers fails the liveness probe, it will terminate that container. And what the readiness probe will do is that if any of it will check the service of the container, that it is it able to handle the request and handle the traffic. So if any of the container fails in readiness probe, it will remove the IP address of that pod until unless it gets restarted or terminated. So this is how the self-healing mechanism works in RTF. Then coming to the horizontal and vertical scaling in RTF, that how we do the horizontal and vertical scaling. So we can do both horizontal scaling and vertical scaling in RTF, which is used for testing the capacity and the performance of your container and the pod. So in Kubernetes, a horizontal pod autoscaler will which automatically scales the workload is not possible in RTF. You have to manually increase the number of replica for horizontal scaling and vCores and memory for vertical scaling from the runtime manager, which is the control plane provided by the MuleSoft. By providing the number of replica, when we run that in a cluster mode, the request is then distributed among the different replica, and it will lead to the efficient load balancing. That if there are n number of requests, that will be divided between the different replicas, which will decrease our average response time. So to do the horizontal scaling, which did a small demo part, for example, we use the JMeter for the horizontal scaling. So what we do is that we pass we put the different replica per application. Like we were using one replica per application, then we provided with the we just double the replica for per application. Like we put the replica to up to twice or thrice, and we check the performance, that how our response time is getting varies by using different replica per application. So as you can see in the first screenshot, that I'm using one runtime instant per application, and it is giving me around 2700 milliseconds, which is very much response time, which is giving me. And if we were we were giving as more as number of requests, which is around, we were passing thread group of around 50. So the response time was keep increasing. At the starting it was not increasing, but in the end of the test it was increasing, because the all the load is going to the one replica, because we have defined only one replica per application. So what will happen if we'll be increasing our replica per application? If we'll be putting two replica or three replica per application, that average time decreases manually. For an example, if we use two replica per application, it was giving us around 2400 milliseconds. And if we'll be using three replica per application, it will be giving around 1000 milliseconds. So this is how the response time varies. The more the number of replica, the less will be your response time, because that load is handled, the number of requests or the which we are receiving, that will be handled and distributed among different replicas. So that also depends on your use case, that how much replica you need for your application. So this is how we can test for horizontal scaling. Then talking about vertical scaling, you must be familiar with the fact that for the vertical scaling, we assign more values, which is the V code and the memory, to a particular runtime, to your nodes, and this can also be achieved by using runtime manager. And as you can the screenshot, you can see that we have a section called resource allocation, and then there we can assign our vcores and memory, that we have reserved CPU, then you can mention the CPU limit, then you can also assign the memory. So for vertical scaling also, we did a very small test, that is we used very simple Java project to see that how the vertical scaling works. Like for example, in the very first, you can see that we assign the memory around 0.7, and then we tested out that we got to know that it was using around JVM total memory of around 187 MB. And when we double that memory almost to 1.4, it was using the JVM total memory of around 155 MB. So this is how you can test for vertical scaling, that how much vCores and memory you want to assign for your application. Also, that depends on your use case and business case which you are doing. Coming to the next topic, which is the report generation and do the backing up the RTF. For the report generation, so report generation is very important when it comes to monitoring and troubleshooting for the RTF. So for that, we can use the RTF CTL command line utility to locally manage our RTF, which is also used for various other tasks also, not only for report generation. We can do the backing up the RTF, we can restore our RTF, we can even update and apply the new license key, etc. So for report generation, you have to use the command, which is the RTF report hyphen file and name of your report name dot zip. By running this command, it will generate a zip file that we need to extract. And after extracting that, we'll be getting our report in the different namespaces. As in the screenshot attached, you can see that we have different namespaces. For example, we have default, then ingress nginx, then we have cube node lease, cube public. So these are the different kinds of namespaces which the report will be generating, and this report will be containing the information of your deployed application, or about your pod, which contains like when did your pod start, your IP address, then the status and the number of replica which you used, and the logs and other different factors. Also, we can take the backup and restore the RDF whenever there is any system failure occurs, or if any of our container fails or pod fails. So we can back up and take the restore of the RDF. For that, you need to run the command, which is the RTF backup, name of your backup file.zip. By this, you can take the backup of the RTF, and for the restore, the command is almost similar, which is the RTF restore, name of your backup file.zip. By performing these two commands, you can take the backup and the restore of the RTF. Also, while performing a backup, VM snapshot is not supported. And after taking the backup, if you made any configuration changes for your deployed application, that is also not restored.
Beauty, can you reshare your screen because the presentation is coming very small?
Okay.
Yeah, just share your entire screen.
Is it visible now
Yeah,
properly?
it's visible. Okay.
Okay. So this was what about backup and the restoring the RTF. So then we have the tokenization and detokenization, that how we perform tokenization and detokenization. So when we can use the tokenization, we can consider a scenario. For example, we are passing any payload to the Mule application, which, and in that payload, for an example, it consists of any credit card number, and that payload is getting being logged into that Mule application, so anyone can see that credit card number. So for that, tokenization comes into the picture, that we want to protect our sensitive data. So what does tokenization do is that tokenization will convert your sensitive data into the non-sensitive substitute, which is called token, which is a random generated string. And sensitive data can be of different forms, like it can be your PAN card number, it can be any credit card number, or any PHI, which is your protected health information. Tokenization comes with lots of benefits, like it will increase your security, which is that the data breach will be almost neglected. Your sensitive data will be converted into a token. Then after that, it will increase your performance. And after, we have the benefit that it will provide us with the flexibility and the vaultless operation. So if I have to explain that how the tokenization works in this screenshot, as you can see that we have a client, and then which we are calling a Mule application. And after that, while calling in the API gateway, you have to apply the tokenization policy. So for example, in this payload, as you can see, if we are passing a credit card number and order, so it will call the API gateway where the tokenization policy is applied. So that tokenization, then the API gateway will establish a connection with the tokenization service, and it will convert your credit card number into a random string, which is a token, and then it will pass that token to the API gateway, and then the API gateway will change your credit card number into the token, and then that token is passed to your Mule application. So this is how the tokenization works. So in the API gateway, you have to apply the tokenization policy. We also have the demo part for the tokenization and the detokenization. So we'll show you that how we can do the tokenization and detokenization in the demo part. And talking about the detokenization, this is almost similar to the tokenization policy. It's just that this is the process of returning your previous sensitive data to back to its original value, which we converted into a token. And this can be used in a scenario. For an example, if you're using an application which consists of any bank account number or credit card number, and you want to generate that, so then you can make use of the detokenization. So after this, we have forwarding logs to external services. So whenever we deploy our Mule application, logging is the most important part which is needed, because for monitoring and analyzing our application or fixing any production issues or analyzing our bugs, so monitoring logging is the most important part, and you can perform this in RTF by using the kubectl command, which is the kubectl log, name of your pod, and hyphen n and the namespace. But if we want to see that, we want to see our logs in any of the GUI. So how we can do that? If a client of a person have the Titanium subscription, they can forward their logs to the Anypoint monitoring. But if they don't have the Titanium subscription on Anypoint platform, they have to configure their logs to the any third-party solution. So we can use any of the third-party solution, like we have Splunk, we have Datadog, we have Kibana, others. By using these, we can pass our logs to the any third-party solution. So how we can externalize logs in RTF? Previously, we were using the sidecar logging agent and the daemon set for every node, but they were consuming a lot of resources and they were very complex to configure. So in November 2022, RTF uh, released that we can use a log4j appender to integrate a logging system with application which is deployed in the RTF. And also with the log4j configuration, every parameter is set to be the default, which disabled to the false in the values.yaml. So we have to set that value to the true. So how we need to set that value from false to the true, Ishil gonna show you that in the demo part, that how we can configure that. And then after that, we have to restart that runtime fabric agent, and then we have to restart our application. This is how we can configure the logs. As you can see in the screenshot, that custom log4j enable should be value should be true. By default, as I mentioned, it is set to be false. So after this, Ishalveer will going to show you the PPT demo part for the tokenization and the detokenization and the forwarding logs. After the demo part, we'll be covering the other topics. So over to you, Ishal.
Yeah, thank you, Beauty, for the insightful explanation of these topics. Now we can proceed with the demonstration part for tokenization and detokenization and forwarding logs to third-party sources. So let me share my screen. Let me know once my screen is visible.
Yeah, it's visible.
Okay. So for configuration of tokenization and detokenization, first you need to log on to your Anypoint platform. There, the first thing that you have to do is that in the security component, you have to create a tokenization format first. So let's go ahead and create that in here. Here, as you can see, various security policies can also be configured along with tokenization formats. So here you have to give a demonstrative name for your format. And you can also add in a description for the same. And here in the data domain, you have to select what type of value you expect to tokenize. So you can select from credit card, decimal, lakhs decimal, email addresses, and so on. So if we configure credit card here, we can configure preserve first few characters and the last few characters depending on what you need to do. And then you can see various pre-existent credit card vendors are present here, or you can use a custom credit card formats. So I have already created a credit card tokenization format which we will be using for the purpose. The next step which you need to do is that in the runtime manager you need to create a tokenization service. Now basically this tokenization service will actually be deployed on your RTF cluster in the number of pods you specify in here. So here you create a tokenization service, you give that a name, then you select the runtime fabric you intend to deploy it on. Then you select the number of replicas. This will be the number of pods that will be configured to cater to the service. Then you select the format which you need to give the service to. Then you can select the memory statistics regarding the reserved CPU, the CPU limit, and so on. Then you can build and deploy the service on the RTF. We have already configured a demo tokenization service for the demonstration part. So we will be applying this tokenization and detokenization as a policy on our application, which I will be adding as an instance in the API manager. So first, let me walk you through the API which we will be actually using for the configuration of this tokenization services. So if you can see, this is a very simple Mule application with two endpoints, namely invoke and retrieve. What basically will happen when I hit a request to this post endpoint? The payload will actually contain a credit card number, which will be stored in an object store. And then the second flow, which you can see, which is the retrieve one, will actually retrieve the value of the credit card number from the object store. This will be the same value which will be stored in the first flow. This basically I have done to mimic any business logic that occurs to show you the concept of tokenization. So here, instead of object store, you can have any outbound request connector or something like that. So after that, we will deploy this API on runtime manager after we configure an instance for it. So on API manager, I have created an instance for the same, and we have tokenization and detokenization policies on the same. So as you can see, I have applied resource specific tokenization and detokenization policy. This depends on a particular use case. Like for the simplicity purpose, I have applied it on a single API itself. Moving to the configuration part. Let's give it time to load. Yeah. So you can apply the policy in any of the intended directions. If you apply it on the request, what will happen that the payload that you're sending to the request, the value inside the payload will be tokenized, and the tokenized value will be passed into your mule flow, so that if in case logging occurs or something like that, the tokenized value will be logged instead of your actual credit card number. Or you can configure this policy on the response. Yeah, again, depending on your use case. So here, you remember that we have configured a service in the runtime manager. We select that here, and then this expression will contain data weave for extracting the value that you intend to tokenize. So in the payload, we expect a CC number, that will be a credit card number, and we intend to apply the demo format that we created for credit cards in the tokenization formats. So we have applied it on the invoke endpoint. And let me go back. So the configuration of the detokenization policy is exactly similar, just that we have applied it on the response rather than the request. And yeah, that will detokenize the value that we have in the response. So let me hit this application, which I have already deployed on the runtime manager via Postman, and then we'll infer the logs inside the pod itself. So this is the API which I have deployed on runtime manager. So yeah, if we use the invoke endpoint, I have passed the credit card number. Remember, this is the original credit card number which we pass without tokenization. So what we expect in the response is the tokenized credit card number. Let's see what happens. So in the response, as you can see, the credit card number is not the same as we have passed. So this is actually the tokenized value. And now this tokenized value will actually be retrieved in the this endpoint. So let's see what happens when we retrieve the same value with detokenization policy applied on that endpoint. So you see, actually, this is the original credit card number that we had passed. So this is the functionality that tokenization and detokenization provides us. Now in the response, actually we have the detokenized value, but inside the API, I'll show you the logs that the tokenized value will be logged instead of the original credit card number. So let's get the pod which actually runs this API. We are using the kubectl command line utility for this one. So you see that this is the pod which is actually running this service. So let's copy the pod name and get the logs. And let's paste down the namespace. So yeah, you see inside the API, when the mule flow ran, the value logged is actually the tokenized value, not the actual one. So we applied the detokenization policy on response, and it in turn retrieved the value from the tokenization format of the original credit card number. So this was about the configuration of tokenization and detokenization policy and making use of the tokenization services offered by the runtime fabric. So moving on to configuration of logging in RTF applications. This will be very similar to the configuration of logs in case of any other deployment model. Just the slight difference being that we have to patch a very small property in the runtime fabrics, sorry, the cluster secrets that we have configured. I will walk you through that one. But first, let's configure the Splunk logging in our Mule application. So this is the Mule application. We intend to have the messages logged off. So in the response, I'm logging a message that, hey, this message will be logged. We have the timestamp and the correlation ID. Now, the first thing we have to do, we have to create an instance of Splunk. Don't worry, I have already created an instance of Splunk to save us on the time and have a token retrieved from that to collect from our application. So if you see over there, I have this instance of Splunk already configured. So in that, we have to go to data inputs. Here we have the HTTP event collector. And then we create a new token. We can give demo token the name to it. And then we can proceed forward. In the source type, we can select log4j. This is the one we will be using for getting the logs for our Mule application. Then you can review and create the token. We already have a token in hand, as you might have already seen. We will be using that one in our Mule application. So this is the token we'll be using. Now moving on to the configurations in Mule application. I might guess that you all guys might already be familiar with it. So in the log4j, which is the main focus for configuration of logs, you have to add configuration consisting of packages for Splunk. Then you have to add appenders for Splunk, which consists of the URL for the Splunk instance along with the token that we just got now, and followed by the appender references. After that, the thing that is required in the pom.xml, you have to add dependencies for Splunk. As you can see, this dependency needs to be added. This is followed by configuration of the Splunk repository in pom.xml. So this repository should be added. Now, this is very simple process that we follow in all the other deployment models. But apart from that, what we need to do is that we need to patch the property. So if you hit this application right here, logs will be sent to Splunk. But if we deploy this application on the current RTF, what will happen that if you hit the application, no logs will actually be sent over to Splunk. Let's try that. So I've deployed this application on RTF and let's hit that. This is the correlation ID that we intend to search the logs for. So let's search for the logs. As you might see, no results found. Now here comes the tricky part. You need to use a command to patch the property custom log4j enabled in your RTF cluster. So for that, we will be using this command. We will be patching the custom property secret, and we will be changing value of this key to true. This is actually the base 64 encoded version of the true boolean. So let's run this command on git bash. Let me first clear. Yeah, the property has been patched. The next step we need to do is that we need to delete the runtime agent. So for that, first let's get the pod for it. It will be present in the RTF namespace. If you might have attended the last meetup, you might already be familiar with this. So we get the name of the agent and then we delete it. It's deleted. So the last step we need to do is that we need to restart our Mule application deployed on the RTF. So let's go over there. Let me restart the Mule application. Meanwhile, this application stops. Let me show you in the Azure portal that our property should have been patched by now. So this is our Azure portal. So basically, you might be familiar that we are using the Azure Kubernetes service for configuration of RTF. And over there in the configuration part, we have secrets appearing. So custom properties is the secret we intend to look up for. And in the custom properties, custom log4j enabled, this already was presented by Beauty in the presentation part. So it's set to true now, and we should be good to go once the application is restarted. So starting up the application again. It'll take a few more seconds. So it's starting up. Yeah, the application is started. Now let's hit the request again. Correlation ID that we tend to search the logs for and see now if the logs are forwarded to our logging solution. So let's search for the logs for this one. And yeah, the logs come up. So that's how essentially we configure external log forwarding in case of RTF. Just a small property, custom log4j enable needs to be patched in the custom property secret. So that was about the tokenization, detokenization, and forwarding logs part. Over to you, Beauty, for further proceeding.
Okay, thank you, Ishal. Is my screen visible?
Yeah, it's
Okay. Okay, so now we'll be discussing about the topics which are left. The one persistent gateway, and then another one is the TLS, and the last mile security. So coming to the persistent gateway, how we can store our data if we want to store our data and share the data across different applications. So in RTF, after the version of 1.9, MuleSoft has introduced the persistent gateway. So Anypoint RTF has given us the persistent gateway to store our data, and if you are deploying your application to the RTF Mule runtime instance, that uses the object stored v2 REST API, which is the object stored connector to connect to the persistent gateway, so that we can share our data and store it. As you can see in the picture that if we are using if any other deployment model, how we can store our data, which is like if we are using Anypoint Studio or locally, so in that your data gets stored into the in memory or the external file. For the cloud app, in the backend it uses AWS NoSQL, and if we are using the on-prem, then it stores your data into the in memory and the external file and the or external DB. But in case of RDF, in the backend it only uses the PostgreSQL DB for that. So you need to configure that. And the data which is stored in the object store, that is for the maximum of 30 days. And also I want to highlight that if you're deleting your any of the application which is deployed in RTF, so that data will won't be getting deleted just immediately. It will take few around 60 minutes to delete that data from the object store which is connected to the persistent gateway. And also it's becomes very easy if you're migrating your API from one deployment model to the RDF. For example, if you're migrating your API from Cloud Up to the RDF. So if you are using the Object Store V2, so in that case you don't need any configuration changes. Just that two table which you are using, that need to be copied for your both deployment options. So how we can configure the persistent gateway? So the very first thing we need is that the PostgreSQL DB after with the version of 9 or above, which can be hosted anywhere in the cloud which you're using. It can be Azure or AWS cloud or any Google Cloud services. Then after that, we need to create the Kubernetes secret to make the connection string to the DB, and then we have to create a custom resource template to the configuration which will consist of the persistent gateway. And finally we need to apply that template. As soon as the persistent gateway start, it will create two tables, the table store and the table item. And the table store, it will contain one row per object per application, and the table item, it will contain one row per key value object. We also have the demo part for the persistent gateway. So we will be going to show you that how we can use the persistent gateway in the RTF. So in the end, we have the TLS and the last mile security. So as we know that TLS stands for Transport Layer Security, which is a cryptographic protocol, which provides the communication security for your mail application for over a network. So it offers many different ways also for exchanging keys, like you can use authentication or encrypting data or any guaranteeing message integrity. And talking about the last mile security means that you're using the HTTPS instead of HTTP between the edge and the application. Now what does the edge means in the RTF? So edge means that the ingress load balancer which we are using in the RTF. So as you can see in the screenshot, if we are hitting a request, so it will pass through the ingress load balancer. So for this one, you need to apply the TLS, and from the ingress load balancer, that request is going for your Mule application. For that, you need to apply the last mile security. So the last mile security is configured between the edge and the application. So for the TLS, what you need to do is that you need to install a certificate for Nginx load balancer, and for the last mile security, you need to configure that into the key store and the trust store for one way and two-way SSL for your Mule application. So how we can perform TLS? For that, you need to, very first thing, you need to create a Kubernetes secret, and then you have to apply that Kubernetes secret to the ingress template, the template which we were using. So that is the ingress resource YAML file. And then after that, you need to curl request to fire request over the HTTPS. And then after that, we can see the logs for the TLS handshake. So this is how we can achieve the TLS in RTF. And for the last mile security, you have to add the key store in the API. And again, you have to apply that changes to the ingress template file. And after that, applying the changes in the template file, you have to fire that request over the HTTPS, and then you can view the application logs over the request where it is hit, which is the HTTPS. The one thing I want to highlight is in this one is that if we are using a Mule application in Cloud App and we are using the TLS, so it's going to use the port 8082. But in case of RT, using the we have deployed our application in RTF and we are using the TLS and the last mile security. It's going to make use of the port 8081. So now Ishal is going to show you the demo for these two topics. So over to you, Ishal.
Yeah, thank you, Beauty, for the explanation. Now I would be presenting the demo for these topics. Let me share my screen. Let me know once it's visible.
Yeah, it's visible.
Okay, so coming to the configuration of persistence gateway in our Mule applications, as Beauty already explained, persistence gateway is basically used for persistence of values in object store. Now you can say it as persistent storage. Even if your application crashes or in an adverse event, your values that you have stored in object store won't vanish, and that would in turn cater to our use case as required. So you can see if currently we don't configure any backend database here in the runtime manager of the particular application under the deployment target, you see use persistence object store with a warning that persistence object store is not established for this runtime fabric. Now, what if you try to use the persistence object store in this case, and what is the result that you might expect? Let me first show you the application that I'm using for the purpose. So this is the same application with a different XML file for demonstration. So as you might expect, a simple mule flow with start and end loggers with the store connector to use the object store facility and a retrieve connector to retrieve all the key value pairs that I have stored in the object store, again with the start and end loggers. So these two flows will help us to demonstrate the below the mentioned topic. So we haven't currently configured any persistence gateway backend database for our Mule application in the RTF. Now let's try to retrieve any value that we have in the stored in the object store. So let's hit this endpoint. So object store could not be initialized. So if you're looking out for persistent storage without configuration of any backend database, namely the PostgreSQL one, you won't be able to leverage the functionality of object store. So since we intend to use PostgreSQL for our demo demonstration, we need a cloud service provider or anything like that. Google Cloud Storage, Azure Cloud Storage, Heroku, PostgreSQL databases, anything can cater to our need. But since we're already using Azure Kubernetes service, we will use Azure databases for PostgreSQL. So let's first move over there. Yeah. So our Azure portal has a facility for Azure databases for PostgreSQL. Cloud-based services are basically the provisioning that they do. So over here, we create a database for PostgreSQL servers. You can select any resource type depending on what you want to select. So here, since we are leveraging a free trial, we select that, and the resource scope we want to we want to allocate the resource to. Then we have a server name, the location, version, the computation and storage we want to assign it to, and the admin username, password. This is the areas of focus we need to store these values with us, so as we can do the further configuration. We have already created a PostgreSQL database to save us on our time. So let's go over there. So this is the RTF demo PostgreSQL database that I have configured. So as you can see, I have the username, I have the server name, and then I have the password with me, which I have used for the configuration of the PostgreSQL database. Now, if you see in the MuleSoft documentation, they have mentioned that in order to use the persistence object store, what we need to do in case of RTF, first thing we need to create a database. We need to have our hands onto a database. Then what we need to do is we need to create a secret. So this is the format in which we create a secret using the kubectl command line utility. We add the connection string over here, username, password, separated by @sign, followed by the host port and the database name. So one thing that you need to take care of very much is that you don't want to use any special character in your username. So if you look to our database username, we have a symbol specified over here. So you need to you need to use the UTF-8 characters for that. For escaping the character, you can use %40 for that one. That's very specific to the symbol. For other special characters, you can use other UTF characters. So once we create the secret with this format, I have already created that. So using this, you can see kubectl create secret generic. This is the name of the secret we want to assign the secret. So we need to have this name with us, since we need to configure this in the template file we will create further on. So here we configure the username followed by the escape character, and the password, and the server name, followed by the host, followed by the database name. Then we create a template file. Since to leverage any custom service, we need to create a template file and we need to apply it to the Kubernetes cluster. So this is our second step. First, let's create the secret in Kubernetes cluster. So as you can see, the secret has been created. Now let's apply the template file to our Kubernetes cluster. So you can do it in two ways. Either you can create a file and then apply the file, or you can use cat command and git bash to apply the file. I'll follow this one. So now persistence gateway has been created. Persistence gateway service specifically has been created. So now since we have specified two replicas over here, so this custom template file is specifically for the specification of the configurations we intend to assign the persistence gateway. So let's, since two replicas are configured, we will have two pods for it. So let's retrieve the pods. So as you can see, we have two pods for persistence gateway. So let's retrieve the logs for these two pods. So as you can see, they are running their health check probe to check if they are able to make connection to the backend PostgreSQL database. And we have successfully created the connection to the backend PostgreSQL database. So making the connection over here won't help us visualize what we are doing. So I have used PG admin for help us visualizing the PostgreSQL database. So we have the picture clear in our mind. So this is the PostgreSQL database which I have added in PG4 admin. What you can do is that you can register a server and add the connection strings over here in connections to add your PostgreSQL database. The connection strings are the one which are provided in the Azure portal. So as you can see, I use the store database. And since the PostgreSQL database has now been connected to the persistence gateway, we intend to have the items and the stores table which are present in the database store over here. And as Beauty already explained in the PPT, that the items table would have values for the key value pairs for the object store, and the stores database would have the values for the object store in the RTF. So let us now go over here, and you see the warning sign has vanished. And if in the RTF we see, we would have the persistence gateway configured. Yeah. And in the runtime fabrics, this is our RTF. You see persistence gateway is healthy. So now let's try to hit our application. We post a value by the name Ishalveer and we try to retrieve it. As you can see, we are able to successfully retrieve the value. So this is the concept of configuration of persistence object store in RTF. Now, since we need to visualize this to have things clear, let me show you that what happens when we store a value in the PostgreSQL database. Okay, we have our two tables coming up, and we have the columns. You see ID, store ID, key, partition, value type, string number, binary, and so on. And then stores table. You can see its ID, name, org ID. So any information about the object store we are using. So let's select the values from items and see if the value which is supplied via the application appears here. you see that the value which is specified over here comes up, and it's stored as a binary value. You see that this is the binary value that's actually stored. So if any one of you might have already used the object store v2 rest apis, whenever you retrieve the values of the keys stored in the object store, they come up as binary values. So this was about the configuration of the persistence object store in RTF. I see that we are running late on time, so should we present the POC for TLS or should we go ahead with trivia, Avneesh?
As you like it, Ishal. Um,
Okay,
yeah,
so it'll gonna be a short demo only. So let me
so,
go ahead with that
yeah,
one.
go for
So
it.
currently we are listening over HTTP. So our request from our end and to the Nginx load balancer are going over HTTP. So when we configure the TLS, what will happen that we will be listening over HTTPS instead of HTTP. So for the first part, what we need to have is with us the certificates that we need to apply to the Nginx load balancer. You can use OpenSSL commands for generation of the certificates. I already have the certificates in hand to facilitate the process. So cert.pem and key.pem were generated using the OpenSSL commands. I have the commands listed down here. So you see, I have used this command for the generation of the certificates. And again, in order to leverage any custom service, what we need to do is we need to create a secret. So going ahead, we will create a secret to apply these certificates to the Nginx load balancer. Okay. Oh, so I've already applied them. The secrets exist. So once we apply the secrets, we have to apply this template file to our Nginx load balancer. You can see over here, we have specified the secret name, example TLS. So what it'll do, it'll apply the TLS to the Nginx load balancer and we will be listening over HTTPS. So let's apply this template file using the command. So it has been configured. Now, if I go over to the ingress that I have specified for RTF, you might notice that if I refresh the page, we would be listening over HTTPS. You see, it's HTTPS now instead of HTTP. And if we move to any of the applications that we have already deployed, you might see, okay, let me refresh. Yeah, now we need to select a host that listens over HTTP and we need to apply the changes. So yeah, let's apply the changes. Let me hit this request using a curl command to visualize the handshake that took place. Okay, the application is restarting. So the application has restarted. Hmm. Oh, I have specified HTTP. As you can see, the certificate happened. Certificate handshake happened. We are exchanging certificates in the TLS handshake, and here we have the value for log retrieved. And yes, now we are listening over HTTPS. So For the configuration of last mile security, that's not something very alien to us. It's like normally configuration of the key store and trust store in the individual Mule application, so that once we are able to receive the HTTPS request to our Nginx load balancer, so as to receive the request over HTTPS to the individual Mule applications from the Nginx load balancer, what we can do is we can configure the key store and trust store in individual Mule applications. So yeah, that was about the demonstration part for uh, object store and TLS and last mile security. So following this, we have a very interesting trivia for all of us. So let me start the trivia and I'll give you a link on which we can register. I request all of you to go to www.menti.com and I'll hand you over a code which you can use. So you can use the code which I have pasted in the chat section to go to menti.com.
You're not sharing your screen.
Yeah, just a second. Okay, so we have 11 players that have joined in. We'll wait for a couple of minutes more. We got new emojis in Mentimeter. I guess we're good to go, right?
Yeah, let's do it.
Okay, so we're starting up with the quiz. So the first question being, which databases are supported for persistence gateway? Okay, the PostgreSQL database is the right answer. Okay, so everyone are on the top. Okay, moving on to the next question. How can we externalize logs in the RTF? Okay, so all of the above was the right answer. So Naveen Prasant's leading, followed by Shriyanshi and Clippy. Moving on to the last question for the day. Which command line utility is used to take the backup of RTF? kubectl, rtfctl, azure CLI, or none of these? Okay. So kubectl was the right answer. And Chiransi, you're the winner. Okay. So yeah, congratulations, Shriyanshi, Prasad, and Anuj. These are the winners for the day. Yeah.
All right, requesting Anuj and Priyanshi and Prasad to just give us your email IDs, and we can send something to you from our Chandigarh MuleSoft community, and we'll be in constant touch with you. So yeah, we are a little above time. We always try to time box our meetups for 1 hour, but I think the topic was a little elaborate, and I hope that all of you got some value out of today's meetup. I wholeheartedly thank each one of you uh, who participated in today's meetup, and request you to, if any one of you would like to be a mentor, you can reach out to me, Avneesh Sharma, on LinkedIn, and we can absolutely accommodate you as one of the speakers in the Chandigarh MuleSoft meetup. And yeah, thank you everyone for joining in. It was wonderful. Thank you. Have a good one. Bye bye.
Thank
Thank
you.
you,
Thank you,
everyone.
everyone.